Are there any big mysteries left in physics? The short answer is yes, and it is so according to actual physicists. There's an agreement that quantum mechanics, which is the physics theories of the small particles that make up atoms, and theories like gravity, which is the theory of how big objects move relative to each other. These theories aren't able to combine. And you might say, well, that doesn't make sense. We could clearly see everything in the universe being in one place. Objects that are gravitating towards each other are made up of little particles. So, why can't they be combined? And, well, if anyone figures the answer to that out, they'll probably figure out the answer to the universe. But that's with the math. The problem is with the math and the experiments aren't able to find out enough at this time. But most physicists agree that there should be a theory that covers everything, and it'll be called the theory of everything or the unified theory. But what if you're not a physicist? You just want to think about it. A lot of people are turned off from doing this because they think that like physicists are more on it, and it's hard to understand anything they're doing if you're not trained in the physics and the math. And it's true to some extent because physics is very precise and making very complicated measurements. But because of this, there becomes a lacking in imagination. Because if you imagine something that's very kind of open or very peripheral, it becomes something you can't calculate. You calculations happen in a precise way. For and And we have some imaginative theories about these higher dimensional physics theories that are kind of lacking, though. Like, based on like quantum physics idea that we're not really sure how a particle, chooses where to go. It seems there's a lot of places it could go, and it seems kind of random. There's a theory called the multiverse theory that thinks that the particle goes in different directions all at once, and it creates many universes. And I think that theory is limited because it's still stuck in this world like we could imagine. Like we imagine this seemingly material world, I could touch things. So I can't it's hard for me to conceive of a higher dimension, so I could just imagine that the higher dimension is many the same dimensions like this, like the same. And also people often get stuck in the math, it's a good math, but you get stuck in it. Like we think of three-dimensional objects. Like everything is in this world is 3D. Everyone knows this word, children know it. But is it really 3D? It's 3D because you could calculate height, length, width, but each of those measurements is one straight line. It's all one-dimensional lines. It's mathematical lines, and people sometimes think of other dimensions, other universes. They think, oh, like I'll imagine a 2D universe or a 1D universe, but those are impossible, possibly, because a 1D universe would be infinitely thin, a 2D universe would be infinitely thin, and this isn't exactly a 3D universe necessarily. We don't know that. I mean, we have objects are round, and maybe they're as round as they could be. If there were any rounder, it wouldn't make sense because a circle, a sphere has many sides, like infinite sides, and if it was any more infinite, we'd basically be talking about a higher dimension, which isn't necessarily like a object that you could calculate mathematically. We're talking about an object outside of space-time, which is kind of what physicists have been saying like since Einstein. But when it's communicated and calculated and stuff, you can't really talk about these kind of esoteric kind of very like things that even your imagination can't grasp, and math can't grasp it either. It's just the way it is. It's just how it is. It doesn't mean we're stuck. Okay, people have continued thinking about this stuff, but there's a split. There's people that think oftentimes in like spiritual things, and there's people that think in science, and they don't really collide. Where this people that focus more on spirituality, or I'm talking about like New Age spirituality, where people are not connected to a specific religious technique, where they're just focused on their own conscious experience, and they use language from physics, vibrations, magnetism, quantum. Just throw these words around, and they're not wrong because they're thinking about, or you are thinking about, the way the world has been described in the best way it has been described so far, and connecting that with your personal experience. And some people who are more in the intellectual circles would think, well, that's just foolish. But is it really foolish? Well, one of the other main scientific mysteries is the mystery of consciousness. So along with the unified theory of quantum physics and gravity, we have the mystery of consciousness. And the mystery of consciousness is your experience, your personal experience. Why AI is not conscious, and we are conscious. We're not just functioning on an algorithm where it's like a bunch of billiard balls just going boop, boop, boop and give you a result. I have a top-down knowing of what I experience. And it sounds a little wild because it's not in like normal scientific theory, but this is a serious topic to think about if you really want to think for yourself. I mean, this is a well-respected and persistent thing to think about. It's coined by, there's a term, the hard problem of consciousness, coined by David Chalmers, philosopher. And some people think that to solve the universe, it would solve automatically consciousness, quantum physics, gravity. And maybe so, but I don't know that we could really solve it necessarily. We could really just imagine something, and then based on that, if you imagine it right, then if you really figure out a place, you can make an experiment and that will prove something we didn't know about how things work. So you could predict something. That's an experiment where you predict something, but in this case, we're thinking about, like, I don't know how you would calculate anything. Like, what is there to calculate about predicting consciousness or something? I don't know. But it's still interesting to think about. And Another thing to say about physics that and consciousness is we know that we get into habits, like of how we think. We try to make the world predictable. You don't want to be surprised. Like when you see a tree and you're walking around, you just say tree, tree, tree. You don't need to like look at all the little patterns and the light shining on it and the shadows and all the you don't have to really look at it. And, you spend a lot of brain energy, and especially something like physics could give you an existential crisis if you realized how much mysteries there were, and there really are. I mean, there's no solid thing that we really could touch and say we know really so much about it, because every object is made out of particles. Those particles are kind of a mystery how they work. It's the quantum physics. You have everywhere electromagnetic field. What is that? What is radio wave? What are radio waves traveling in? They're not traveling in the ear. They're traveling in this field. We know what it is in the sense we could calculate something on it, like how, the waves that are coming. But like, what is this field in the first place? Gravity. Two objects could be pulled to each other without any strings attached. How is that done? Well, since Einstein, the common kind of explanation is that space gets warped in between. But what is space? Before Einstein, there was an idea called the ether, where space was this kind of substance, and the light waves traveled on this substance. In other words, like when you splash something in the ocean, it makes a wave, right? So those waves are not separate from the ocean, they're traveling on the ocean. So people thought that light waves are traveling on this ether. That's what it was called. And it was disproved by this guy Michelson and this other guy Morley, who measured the speed of light being on different parts of the earth that would be rotating in different directions, and that the speed of light was the same regardless of how they were moving towards the light. And this is from where we get all this Einstein ideas about light, which are very confusing, but they're proven to be true, and in an experimental way. And the basic takeaway is that light is a constant speed, and that nothing could be faster than it that we know of. And there's a lot of implications about the structure of the universe, and there were accurate predictions, and like black holes and stuff like that. But my question is, what is space? If they've taken away the ether, I mean, the ether was a good idea, right? Like, what are light waves traveling on? Now it's like, that's a total, I don't know, you figure it out, you know? And like, we're all familiar with the idea about time, space and time, seeming to be some kind of illusion, that we're not seeing the whole picture. And we have that from Einstein, but also Kant, the philosopher, the German philosopher. He thought about it, like maybe 1700s, I think, and he was a philosopher of mind. He just explored his own mind and came to a conclusion that we can't really know that space and time are real just because we perceive it, because that's a function of our existence. We exist in time. And he said that you can't really use math to really calculate the whole, what do you call the thing in itself of outside of us, because math is subject to time, because you have one thing followed from another, so this, then this, then this, or space, I guess, because geometry requires one thing is here and one thing is here. You can't have a more, like, some kind of blended version of that. But there are many indications that there is this higher dimension that it's hard to understand. And people try in the scientific language to understand it, and it often, I think, fails, because it is like they end up like drawing some kind of weird shapes, or thinking that the higher dimensions are very small and hidden, because they're thinking still in this mathematical language, which is, I mean, a great, very precise language, but it's like it's not expansive outside of space time. It is used to indicate that there is very likely, or you could say for sure, some kind of higher dimension. Well, haven't people throughout history always thought about, in all cultures, thought about a spiritual world, where from their consciousness they thought there's some higher dimension, and it was, wavy and mystical and somehow immaterial. Well, how accurate could that be? I mean, is the universe really trying to hide from us? Maybe, like, there's no reason that the universe would really make these puzzles hard. It just, as we're trying to get more precise, maybe we have to struggle to go beyond our own intuitive conceptions. But what would that mean? A kind of a mystical higher dimension. I'm not talking about like really connecting this to religion here. You could be religious or not religious, and this could be interesting to think about. What I'm talking about is an idea of space and time being like a separation. You have time as a separation of I'm here and now I'm here. And these are two distinct, they can't be blended. There's here and then here. And spaces, this is here and this is here. And so the way so my best guess for a higher dimension would be to simply describe it as those categories will be broken down, and maybe it's a spectrum, and it goes towards a total oneness, and towards this separation. How that works, or would work, I don't know. But we do see in the physics idea of total onenesses in terms of the Big Bang and black holes, where in the Big Bang, according to the math, it's, or from what I've heard, I don't know the math. At the nucleus of the Big Bang, the categories of space and time break down, and it was just infinite in mass, time, whatever. So with the scientific physics, you can't go past the Big Bang very easily and think outside of it. But if you're trying to enjoy the mysteries and just think, you know, just for, you live in this world, you have the right to think about this world, and maybe even a duty. So that's something to think about. But it might not be worth it to think that far, because there's really very little to grab onto. Where it just so I don't know, like it just there. Um, and why did the world come to be? Like, how did it split up? Like, I don't know. Interesting question that I've had after trying to think about the Big Bang a lot is, if the middle of the Big Bang had a infinite density, when it turned into the universe, how did all the particles that make up all the atoms and all the atoms, how did they end up having a consistent size? What I mean is, like, you have like a bunch of atoms of similar kind, and by the way, all the different elements, all the iron, or different elements are. What's different about them is the amount of particles, or energy, electrons, and the distances they are from each other. So, I mean, physicists have a kind of a calculations to do, and then there's illustrations that we all get to see, which are they're not accurate. They're just representations. People have tried to speculate how atoms actually are, maybe more cloudy. People call it the electron cloud, rather than just one electron going around. But there is this idea that the electrons are a certain distance from each other, and there's like no in between. It's either here, 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 and that's actually where the from quantum physics comes, I think. Or, yeah, I remember reading about that, and it's this idea of why are they quantified like this, like at this distance. And we often forget that quantum physics is about atoms, like how regular atoms work. It's not just about these experiments where we split up the atoms and see how the particles within the atoms are somehow still connected. It's these experiments, we're supposed to bring them back towards our idea about just regular atoms. But you don't often hear people talking about that. But anyway, why are all the atoms like the same size that they could stack up together and build structures? What I mean is, like, if the center of the Big Bang was infinite density, how does that, we can't even describe it, matter, like some energy, I don't know, like, how did it split up into these consistent sizes that could be stacked up together? Why aren't some atoms big, some small? Like, what's the rule there? And the best idea I've had so far is to think of it a little more like the way we think of information, that the atoms are a similar complexity, not a similar size, that the size is more, not an illusion. I don't like to totally let go of spatial thinking, but like a kind of a combination of what we think of information and the way we think of space and imagination. But that's a kind of scary thought for me, to think of the world as information, because I don't like things to be so abstract. Another interesting thought is, like, we have a multiverse idea. It's not that, how come maybe, you know, maybe we have many multiverses, and one of the reasons I don't believe it is because what would be the boundary between these multiverses? Like, why can't they just blend together? Like, you look at the moon. Which moon is that? Like, does, for each decision I make, there's another moon that I look at, or are all the me's looking at the same moon? And then if you think about it, why not just have a separate universe for each particle? Why do so many particles live in the same universe? Why not imagine each particle as having its own universe where it's totally isolated? How come they're all here together? And also, in terms of the Big Bang, another thought is, where was the empty space before the Big Bang? Was it inside that dense, infinitely dense orb, or was it outside? Or is it a whole other thing altogether? And those are my thoughts about that. I hope you enjoyed. Bye.